So yeah, today I'm going to present one of our research that we did it in Harvard. This is an AI-based ultrasound system that we designed for screening and staging thyroid cancer. So first, how the radiologists make diagnosis of the thyroid cancer. So it's mostly based on the perception. They just look into the thyroid ultrasound images. They look into the size of the nodule, appearances, if it has any kind of weird shape like spiculated nature or any kind of irregular shape. And based on that, the radiologists make their diagnosis whether the patient needs any further evaluation or maybe surgery or anything else. But as you know, like those are mostly based on perception, so it can vary from human to human. So how can you do better? So we can see that it's mostly subjective. So you can see from this figure an image like this dog or a donut. So they almost look same, but how you can make them more distinctive? That's the goal. So we want our model to be more quantitative, more precise, and to be precise to everyone. So one way to get information from the images is called radiomics. So radiomics is a method by which you can generate uh, quantitative features from any sort of images or any sort of region of interest. So these features can be divided into different categories, different texture features that you can get, uh, or some histogram-based features, or even first order statistics, which usually explains the pixel intensity from an image. The next one is a topological data analysis. It is more advanced ones. So here actually, like topological data analysis considers the image as collection of data points, and um, it tries to get a global perspective of the data by combining the nearby pixels together and tries to make uh, like more information from the image. I'm not going much details as I don't have much time, so I remove some slides. But yeah, TDA is a very interesting area to go over. Next is a deep learning. So deep learning, as everyone knows, it's a more booming area of research nowadays. So in this area of research, we are using for convolutional neural network for imaging, because ours is a image and it was a 2D image, so we didn't need to do for 3D convolutional network or something. Now, the people can say, what is the benefit of a multimodal approach versus what is the disadvantages? Because every one of this method has some advantage or disadvantage. So that's why, do you want an unimodal or do you want a multimodal? So for example, radiomics. Radiomics is a very established technique. It has been using for quite a long time, and it has been using quite a lot all around the world by every every reputed research groups. But the disadvantage is it is very sensitive to the noise. If a image is generated from multiple machines for the same patient, for example, you may get different features, different texture features. So they're not stable. Now comes to TDA, or topological data analysis. They are usually more robust to noise, and they are more focused on the global structure rather than the local, as provided by the radiomics, which is more like texture-based features. But the disadvantage is it's more, I mean, even though the topological data analysis is older in algebraic topology or mathematical field, but it is more newer to the statistical data science or image analysis in that matter. And deep learning, you don't need any kind of segmentation. There's a benefit, at least for our procedure, or any kind of feature selection. But the disadvantages are, like, you generally needs a large data set, or sometimes the quality of your network prediction usually depends on the quality of the training set. If your training set is like all noises and not a good data, then you are not going to, you cannot expect good predictions on your test set or any unseen data set. And also it is a black box prediction. So I mean, there are several methods are there to explain it in some manner, but yeah, you can still call it a black box. So thyroid nodules. So thyroid nodules are very common, and it's more common in Asia, in China, Korea region as compared to US, and it's mostly occur in women than men. Usually, the thyroid cancer can be divided into multiple different subcategories. For example, like most of the thyroid cancer, almost 75% of them are papillary thyroid carcinoma. And in this project, we also work with the papillary thyroid carcinoma. And after that, the second largest was the follicular, followed by medullary and some other type of cancer that are available. So current workflow or management for thyroid cancer. So at first, the radiologists actually go through the transverse or sagittal view of ultrasound, and there is a scoring mechanism called TIRADS, and they actually look for each of the nodule for the 5 different categories, and they score them. So after scoring the nodules, they add those score up, and that is called the TIRAD score. So now if your TIRAD score is greater than 2, you go for a fine needle aspiration, which is an ultrasound guided biopsy. And a needle will be inserted and try to take some tissue sample from the tumor or the nodule.
Yeah, Dr. Rahul, can you finish your presentation because we are already short of time?
Okay, sure. Okay, so we established a pipeline, and yeah, so we have almost 1,400 patients, and we also validated our model from some outside databases, and you can see the outside database performance is quite well. And after that, after finishing up the malignancy, we move to more clinical or staging for the cancer, like T stage. The predictions are quite good. T stage and stage extracapsular extension, as well as BRAF mutation, which is a common mutation for papillary thyroid carcinoma. So in conclusion, we created an AI platform to predict malignancy and surgical and genomic outcomes. And we showed that different AI models can provide you like different information. If we integrate them up, you can achieve more reliable and consistent performance. And in this study, we also use multi-center studies, which can be crucial for validating any model's acceptance. And yeah, this work has been like shown in some of the like I mean, this work has been taken in some of the media as well. And